Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, in our previous sessions we have discussed the normality assumption, and you have learned how to find out whether the data sets we have are, particularly the error term, is having the normal distribution or not, right? This is really important for the model. Okay, now once again I'm just letting you know to learn how to check the normality, right? The whether the error is normally distributed, whether the error term is normally distributed. Also, if there is normality issue, if the error is not normally distributed, then what are the solutions? Have to correct that, right? So click on the file. I'm importing my file from the Excel, and the file I'm just using for this is okay. First, dear students, I'm just checking whether the data is normally distributed or not. So this is a not relevant variable. I should drop it. Okay, just break our dependent variable. This is performance, salary, and expenses are independent variable. So keep in mind, dear students, this output is just not considered unless I'm sure about the normality issue, whether the data is normally distributed or not. And when we are talking about normality, so once again, this is really important. We are talking about the error term, whether the error term is normally distributed or not, right? So that's why you should predict the error, which is residual and comma rigid. Okay, this is the error term, and now just check whether it's normally distributed or not. Okay, we have many methods. One is the histogram method, and the QQ plot method, and SKTest, right? So first, I'm just running the SKTest method. SKTest is a command which is checking for the skewness and kurtosis, right? So SKTest and residual. Press enter. Okay, the p-value is less than 0.05. Sorry, greater than 0.05. It means we are failing to reject the null hypothesis. This is really favorable. It means the data is normally distributed. There is no issue of normality. Okay, the probability of the skewness and kurtosis, they are also greater than 0.05. It means there is no issue of the normality. Okay, now I have to make sure using the graphical method here. Just click on the histogram and choose the residual. Click on the density plots, add normal density, and okay. Okay, look, dear students, this is once again, I'm just teaching you how the normal distribution curve looks like. So the data is just fitting and say that the error is just normally distributed. So the graph is confirming the data is normally distributed, and also the test is confirming the data is normally distributed. We have one more method, dear students, and this is the QQ plot method, right? Simply, and this is just, you should type Q norm, and then this is click on the residual and press enter results. In this graph, if most of the points they are on the line, this means the data is normally distributed. But if the points they are deviated, you can say there is the issue of normality, and the data is not simply not normally distributed. Okay, this is the situations where we have no issue of normality. If this is the result, we can just directly use this data results and report your the output for the SKTs or the skewness and kurtosis, and claim that there is no issue of normality. Okay, we have one more method users, and that is the Shapiro-Wilk method. Okay, you can also use this method. This is very much common for the checking normality, right? Okay, you should type SWILK, SWILK, okay, and space clear on the residual and press enter. Okay, the p-value is greater than 0.05 resistance, so you can say we are failing to reject the null hypothesis of normality. So the data is normally simply normally distributed, right? So the SKTest method, the histogram method, right, and the Shapiro-Wilk method, this is all of these methods just they are indicating that there is no issue of normality resistance, right? Okay, here also have mentioned the Jark-Baratis. This is just, you should type the JB and the residual, but this is just not working here because this is the older version. Okay, conclusion, since you have learned that if there is no issue of normality, right, then the p-value should be greater than 0.05 in any kind of test, sorry, in any kind of test you are using, whether you are using SK test or you're using Shapiro-Wilk test, right, or you're just using the graphs. You can just observe whether there is normality or not, right? Okay, now once again, I'm just using a file with which there is the issue of normality, right? Or you can say that data is not normally distributed. So if we have a file here, in this situation, I'm having this file. In this file I have the issue of normality. Okay, very simple. Just run regression, take your dependent variable which is performance, experience and salary, and press enter. Look at the results. This is the output and you should predict the residual. Why? Once again, why? Because we are checking the normality in the residual, right? So reset, and now this is the residual. Check the normality. We are using the skatist. Click on the residual, press enter. Okay, here the p-value is less than 0.05. It means we are rejecting the null hypothesis and claiming that there is the issue of normality. It means that there is not normally distributed simply. And also the value of kurtosis is less than 0.05. So this is further confirming that there is the issue of non-normality, right? And from the graph, click on the graphics, and here we have the histogram. Check the residual and density plots, and I just click OK. Also here users look into these bar, right? So the graph is just not suited for this, so data is not looking normally distributed here. So the graph is confirming that data is not normally distributed. The SKT is also telling us that data is normally distributed, right? Even if you are just checking further this, all of them, they will give you that the data is, that the error time is not normally distributed, right? Okay, now what are the method how we can remove or correct the issue of non-normality? Number one, you can use the log transformation method, right? We are transforming the dependent variable. This is something you should learn yourself, that when we are correcting the issue of normality, we are just transforming the dependent variable. Why? Because it is the dependent variable which is just causing the issue of normality, because the error term is part of our dependent variable. So that's why we are just transforming the dependent variable. And we say the coefficients, we are talking about the coefficient, right? This is really important point. I just want to try to highlight for this purpose. That's why I'm just telling you why we are transforming the dependent variable. And the model distance, why we have beta naught and we have beta 1, right? And we x1 and we have beta 2 x2 and error term. Keep in mind, dear students, this is really important. This beta 1, these are coefficients. In these coefficients, they are the linear function of y, right? It means these are the coefficients, they are just the linear combination of y. So when we are talking about the linear combination of y, then keep in mind that the y is just including the error. This error is a part of the y. So when you just try to know whether there is the normality issues, then that's why we are just checking the error. The error is just part of, and the randomness. Why we are not checking the y for normality? Sometimes maybe students ask why we are just checking the error, because the error is part of the y which is random, and the randomness, that is just creating the issue of non-normality. From the randomness we are understanding whether there is the issue of normality or not. That's why we are not taking directly the y. But this is really important, that you should learn that the y is the variable in which we are just checking whether the issue of the non-normality is here or not. So that's why we are transforming the y value. We have do nothing with the x. So x, or you can say the normality has nothing to do with the independent variables. That is only with the y. Even if they are independent variables in the model and they are not normally distributed, but it is not the issue. But the issue is only with dependent variables. So when we correct our normality, we are just transforming the y. We are using some transformation method, and by transformation we mean we are either just converting the y value to its log value, we are just taking its log value, or we are just squaring the y value dependent variable, right? And then checking the regression, or we are just taking the reciprocal value, just dividing 1 by the y value, right? In all of these situations, then we are having a special command, right? In all of these situations, we are running again the regression resistance and checking whether there is the non-normality issue or not, right? Okay, so what is the transformation method? We are transforming dependent variable using different method. One is the box-Cox method. Is also one of the method, inshallah. I'm just teaching. So first, I'm just using the log transformation method. It means we are just converting the dependent variable, right, into its log value, right? Its log value. And what is the command? Generate the log of y dependent variable and use this command. Okay, simply here I'm generating one log value of dependent variable. This is our performance, so I should type log and performance. Whatever name you are choosing here is not an issue, but after equal sign you should type log, and the bracket, whatever is the, what is the spelling of performance, you should just directly put the spelling of performance and press enter. Now we have created the log performance. It's a dependent variable, and now dear students, you should run the reg and take this dependent variable and all of other independent variables, right, simply, and press enter, dear students. Now in this output, dear students, we have just transformed the dependent variable and we have used the log value. Now you should check once again whether there is the issue of non-normality or not, right? So just you should predict the residual. But keep in mind, we already have residual, so this residual file should be different. So you just use the residual by the name of log and type reset. Okay, now we have one more residual log, right? This is we have just created from this output. And now check this, dear students, if we have the issue of normality or not. So you should type skTest, and this is our residual, and press enter. Okay, once again the p-value is less than 0.05. Why? We have just transform our variable previously, right? We have just taken the log value of our dependent variable, right? The purpose is to check whether the issue of non-normality resolved or not, but we found out that yes, once again there is the issue of non-normality. It's really not solved. The value is less than 0.05, and when this value increases from the 0.05, it means the issue is just resolved, right? Now, so you can say the second method, the first method measurably failed. It did not help us, right? So now we come just into the second method, which is square root method. In the square root, we are transforming this y value, right, into its square root. Just take the square root of the y value. We have a special command, right? So you should type the gen and square root of the performance. This is my dependent variable, and equal sign, and this is command generate square root. I just take the square root of what? The performance. Okay, now we have created one more square root performance. Now I'm just using again the regression and take this to a dependent variable, and all of experience and salary we have, these are independent variable. This is another output resource, but keep in mind once again we are just predicting what? The residual. This residual should be different from these two residuals. I'm just using the SQRT residual, right? And reset. Now just check skTest and type residual SQRT. Okay, now the p-value resistance is just greater than 0.05. So this is the result we are just needing. Okay, it means the second transformations, which is that we have converted our dependent variable to its square root value. So now the issue of non-normality resolved. Why? Because the p-value is greater than 0.05. Okay, you should continue using different transformation methods up to the p-value is just getting greater than 0.05, right? Okay, hopefully the idea is just clear. Okay, the second method work here, students. Now we have many other methods such as the reciprocal method. Here you can just take the 1 over y, and this is its command. You can use the cube root method, right? Okay, you just take the cube root of the dependent variable. Okay, since we have one method by the name of Box-Cox transformation method, and this method we are transforming the dependent variable using this equation, right? So we have y raised to power lambda minus 1 over lambda, and this is in case if the lambda is not equal to 0. If the lambda is equal to 0, then you should not use it. You should just take the log of the value response, right? Okay, what is the Box-Cox transformation method response? The Box-Cox transformation method is just giving us the value of the lambda, and when you get that value, just put it here in this equation, and that is just giving you the transformed value of y, and then you can just use it in your regression, residual, and check for the non-normality issues, similarly as we have just done here. Here, this is also the method of transformation response. Okay, how you can just do it? We are just using this command Box-Cox. Okay, just come here, and you should type Box-Cox, and then put your dependent variable, which is performance response, and your independent variables, which is experience and salary. Press enter response. Now the box Cox distance is just generating a best value of the lambda. Okay, so in this output distance we just consider the coefficient, which is this is the theta value, which is the lambda value, and that is a minus 0.199. So you can say roughly this is minus 0.20. This is the value, right? Now take this value distance, just put it here. Just put it here in this equation, that is giving you the transform value of dependent variable. And have to do it in Strata. There is a special command for that. Okay, I'm just doing it. Okay, so you should generate I need a variable, and by the name of BC box Cox performance. This is the name of the dependent variable, the transform dependent variable name. You should type the dependent variable, this dependent variable, but check in bracket. Why? Because I'm just performing a mathematical function here. So you should type performance, exact spelling, and just raise this performance into the value of lambda, which is minus 20 almost, right? Why? Because in the equation here we have, okay, look at this here. In these functions we have y raised into power lambda minus 1. So I'm just using exactly this function in Stera, right? So performance raised into power lambda. So lambda value is minus, you take it in the parenthesis, minus 20.20, right? And minus 1. Why? Because here in the numerator we have minus 1. So that's why you should minus 1, and this should be divided, the whole should be divided by the lambda, the value. So here we have, look here, we have lambda. So that's why you should divide by lambda, which is minus 0.20. Okay, once again, I'm just repeating the results. This is another method of transformations by the name of box Cox method. We are transforming our dependent variable. We are just using the special lambda value, which is just given by the box Cox, and that is the value of minus 20, right? Minus 20, this is the value, right? And just press enter. Now we have one more dependent variable. This is just another method of transformation. Now, okay, now we have the dependent variable resistance, which is transformed using the box Cox method, which is the special value of the lambda, right? Okay, now run the same regression. Just break and take this value, right? And then your dependent variable. So we have the experience and we have salary, and press enter. Okay, resistance. Now after that you should predict the residual, but this residual should be different from our previous residual, so that's why I'm just using residual BC. This is residual based on the lambda method of the box Cox, right? Okay, so type reset and just use the escape this method and just take this method, right? Residual based on the box Cox method, and press enter. Okay, the value of the p-value is still 0.05. It means this value is still not working here. It's the box Cox method which provided for us the value of lambda still not is helpful, right? So in our transformation method, only the second method worked, and that is the square root method. You can use it simply, right? Okay, according to the box Cox method, other than the best lambda method, we have some other options for the transformation. And that is, if the theta value is minus 1, right, it means you should use the reciprocal method of dependent variable, and if it is 0, then you should use the log method, and if it is 1, then you should not transform the dependent variable. But the p-value of the first method is just less than 0.05. It means the first method is not better method, best method, and the second method is p-value is 0.239. It means the box Cox output is just telling us that you can use this method, which is the best lambda, or you can just use the second method, this one. It means for the transformations, if the lambda value is equal to 0, then you should use the log method. This is just the better method, right? But since the minus 0.19 is just closer to 0 value, so you can use this method also, right? And the third method is that you should not use any transformation method, and that is the significant value is just less than 0.05. It means you can use this best value, and also you can use this second method where the p-value is greater than 0.05, and this is the log method. Since the first best lambda method is not giving you the value of the transform value of dependent variable, why? Because still there is the issue of the normality, then these three methods are also not okay, right? Hopefully you have learned have to find out the have to check whether there is the issue of non-normality, and have to correct the issue of non-normality with different options, dear students, right? Okay, lastly, there is one more method, and this is the U. Johnson's transformation method, which is not used by the Stata, and for that you should use the R, the Python software, dear students. Okay, hopefully, dear students, you have learned how to transform the dependent variable for the purpose to correct the issue of non-normality. Assalamu alaikum wa rahmatullahi wa barakatuh.